we're using the Beaverton-Holt. I can scale this function according to A. And I can construct S, my stock index, according to the weights. I can rescale W and inversely scale A by the same amount. And I can rescale the relationship so that in some of these, the dynamics depends on not just the absolute value, but there are parameters multiplying each other, so you can rescale them in different ways. So that's why that works. So I can say fecundity is proportional to weight, except in the youngest age class, where I assume that fecundity is not proportional to weight, but there's got to be an extra factor that downscales it. So that's what that does. Okay. So then you do the simulation, and then I say explore and comment on what happens to the fishery if the fishing gears switch to a larger mesh size. So in a larger mesh size, what happens is most of the young individuals escape. In fact, if you have a look at these two curves, if I go to a larger mesh size so that I can't capture any of the young individuals, then sometimes I get a curve that looks like B. If my harvesting impacts the younger individuals, when I start to hit the fishery hard, the young are not protected by the fact that their catchability coefficient is 0. So I can start removing, at high Vs, I can remove all the individuals. But if I've got some of the catchability coefficients are 0 for younger age classes, it doesn't matter how high V is, I'm not going to catch all the individuals. Because it's like you're always letting the younger ones go through, so you're always going to have some reproduction. It's also possible to get yield effort curves that look like this. They go up, down, and then, so they're actually asymptotic, not to 0, and they have a maximum. Some of them will look like this. They just keep increasing. Some will look like this, and they may go down to 0. So you get cases where they go down to 0, cases where you get a maximum, it doesn't go down to 0, cases where it just keeps going up. And so you build your model using NOVA. You make sure that everything's discrete. You make sure you got your expressions correct with your parameters. You calculate your yield. And then you run your model until you get equilibrium values. And you can calculate these equilibrium yield effort curves. Okay, any questions? Okay, so that's all I'm going to give you today, because I think giving you this model is a lot of information. So it's a good place to stop. But please go home and look over your notes and try and absorb some of this information. Okay, thanks.